So question for Jose. So
well, I'm just flashed by that, so I can't barely see. Okay.
So would you say that one of the implications from your work on the general intelligence versus social intelligence analysis is that you can have very high general intelligence and the extreme, and not really have very good social intelligence?
My thought about that is that you have very high general intelligence. As a result, you will have social intelligence. So you are able to capture the patterns that are around you. You are able also to construct mind models as well. You can have some facilitators for that, and even with a lower general intelligence, you can do better than others. You have some kind of facilitators with knowing human intelligence. There are several works about that, and why is it the case that some people with lower general intelligence have very high social intelligence. I think that there's a one direction relation between general intelligence and social intelligence, but of course you cannot have a minimum social intelligence without some general intelligence. So there's a close relationship between both things, but still there are some differences, and that's one of the key questions. How can you talk properly as social intelligence, social ability as something different from general intelligence?
So is it more that it's a monotonic relationship, or that you necessarily get the social with the general?
Sorry?
Is it just that there's a monotonic relationship between the two, or that you necessarily get the social with the general?
No, I don't think it is monotonic. We have examples in humans. So in that case, we can, even in animals, you have animals that are they have high general intelligence, and in fact, there's an interesting work in Nature in 2012 by Herman et al. Comparing chimpanzees, gorillas, and humans, and they are barely the same with general intelligence tasks, and the difference is found for the social intelligence tasks. So that's really a hint that social intelligence is perhaps something that we have in some other animals, or we have in a higher extent than other animals don't have. So looking at animals in this area, I think is quite useful, because they have found many counter-examples of things that you think, oh, this is not possible, you cannot find this and this. But of course, that's a relation. The problem is, I'm not sure exactly about that relation. I have some thoughts about that.
Can I?
Just a quick footnote here. I think it's conflated here, the question of training on a specific task and the question of generality. I mean, in my mind, generality means you can learn a bunch of things, but certainly you could be very good at, say, playing chess or in social situations if you just spend a lot of time. Even if we say you imagine that intelligence is a single dimension, and you're very low in that dimension, you can still maybe make up for that to some extent by spending all of your training time on that particular subject. So it's very hard to tease these apart, I think.
I actually have a question. Can I do that?
Are you guys conflicted?
So I was wondering, when you measure, do you measure the relationship between these different properties, or do you measure them separately? Because, for example, when you measure discrimination, it might also depend on other properties in the system, right? So how do you run these tests, and how can you be sure that you're actually measuring this and not something else?
Yeah, well, they are not actually tests. They are just properties that we just get a definition of a benchmark of an environment, and we apply that theoretically. So here, with these bands are not experiments, they are theoretical results. So just, is this property true in this environment or not, or how is the degree of that? So we are not evaluating system with this work.
Okay. But you do set weights, right? When you have the formula of, you want to predict, you do set weights for different properties, or not really?
Well, there are weights everywhere, but we don't combine these properties. We just analyze these properties. We are not going to get any combined property of how social this environment is. So we don't do that.
You mentioned that social intelligence advances our individual intelligence. There are two tasks in psychology that are relevant, which is imprinting and, of course, cooperation that lead to advanced intelligence. So Marvin Minsky has defined imprinting as attachment learning. So the agent, of course, attaches to the ancestor, and it imitates, but it also uses these emotions of pride and shame to elevate goals, and that helps it learn the right things. So do you think the strategy, well, the obvious strategy to use the to designate the user as ancestor to the intelligent agent, robot, and using attachment learning in that way, would it work well, or do you think something else, something more, better is needed?
Well, I'm not really sure I've understood what you're really proposing, but I think that...
Okay, well, I'm proposing, well, it's obvious, right? So you have the user.
Obvious for you.
It's very obvious. There's the user of the robot, and there's a robot. We designate the user as the ancestor of the robot in the sense that imprinting occurs. It recognizes the user, and it does attachment learning.
Yeah, well, I think that this is important in psychology, and what I just presented, and another thing is just going to your question, but I've just presented is I think it's very basic in the way that you don't assume anything about the agents. When you assume that the agent has a minimal, let's say general intelligence with some minimal social intelligence, you can just think about these tests. And any or most of the social intelligence tests that we do with humans, they're assuming a lot of things. They're just indirect measurements, because just measuring this thing, let's say attachment, you can infer that that individual has social intelligence. But when you go to disabled people, you find cases that if you apply that test, you get wrong results, because for some disabled people you can find that, but that doesn't mean that this person is social. So then you realize that that test is not able in general to measure social intelligence, or in general it is something that we can think of, or theoretically you can say you are able to simulate or to emulate some other people. I think imitation is key in social intelligence, but some people are not so good at imitation, and perhaps they are very social, and you find these cases.
Okay, well, just additional remark. Well, yes, but the robot can't possibly imitate everyone, because some of those behaviors would not be preferable. As you don't want to imitate Jihadist John, right? So you might want to have some kind of preference. So that's attachment. Well, in colloquial speaking, it's love, right? So it's loving your parent. Do you think something like an affectionate instinct like that would be actually useful, or would it be counterproductive in the design of the autonomous robots?
Well, you're asking questions I'm not probably prepared to answer, and because I'm not constructing it. So I think all of these should be useful. So because evolution has, in a way, has just found these schemas, or whatever we want to call them, these are useful. Another thing is whether you want to put every possible emotion to a robot. You don't need aggressiveness, for instance.
No, well, so you can...
So that's another question depending, but some of them might be useful, or probably some of the robots that we want to construct will need them, but some others probably are completely useless in the world we are. In fact, if we could remove aggressiveness from all of us at this moment, we would do that, because the world would be much better, probably. So
okay,
that's...
thank you.
Nader wants to say something.
That's all right. I'm not sure if I can answer his question perfectly, but from what I read in game theory, I know that some studies were done where you have values for how much you trust people and how much you trust other agents. And there were lots of simulations that were run where you, at the end of the game, you find how meaningful it was or how important it was to trust one agent or not to trust it. And I'm not sure if we can just replace an agent with a human being and see if this relationship between one agent and another, or one person and an agent, can be simulated the same way. I guess that's all I can say.
Does anyone else have a question? Maybe the panel has questions for each other?
Yeah, I had a question for you. You've talked about, well, a previous version and then the current version, but do you want to standardize in a way, or just to set a platform or something with this that the people can use and create their own benchmark? Is that the idea? Because you started with we had a problem, and then but at the end you have a different vision than from you started.
Yeah, so the motivation was really different from what we actually worked on. And yeah, the goal was really ultimately, and with this paper at least, is to rally the forces, or to get people interested in the requirement spec, because I think, you know, we have a series of proposals for tests for evaluating, but they all have their shortcomings. And, you know, even if, let's say, all of them were implemented perfectly and you could sort of download the test and you run it on your agent, then there wouldn't be any way to compare that to the other tests. And the red thread, for instance, through all that is that, you know, all of them more or less are just focused on measuring performance at a single point in space and in time. And so I think if there's a take-home message from my talk, it's not really, I'm not peddling my solution to how to evaluate AI. I'm peddling my requirements list because I want people to, I want us to collectively search for ways of achieving them in the best way possible. And maybe there's some, as I mentioned in the conclusion, maybe there's some trade-offs in some of them may be more reachable than others. For instance, if there's a strong requirement to have agents, multi-agent systems, then you may have to relax your requirement for complete determinism. But in any case, if the tool set, if you think of it as a Lego kit, you know, if we had a Lego kit where things were at least just a bit more easy to compare than at present, then I think that would be a big step forward. So essentially, even if we make a small improvement on the toolkit that we have for constructing evaluation tests, that would be a bigger step than yet another way of testing or evaluating, or yet another test, you know, a version of the Turing test, or a version of Pac-Man, or a version of Pong that sort of incorporates planning a bit more. You know, anyone can sit down and imagine these things, but they would be isolated islands, and it would be very hard to use the pool of data produced from that in any way, sort of comparable ways, so as to save effort. And everyone who wanted to evaluate anything would have to start very much from scratch, and that would make it, you know, way more expensive than it has to be, I think.
Yeah, but can I? Sure. Yeah, well, my question was a little bit more beyond that. We are a community. I don't know if you have heard about Triple AI this year. There was a workshop about AI evaluation. It was called Beyond the Turing Test. In fact, I wrote a paper with that title in 2000. And they were proposing, and they are proposing, but I don't know what the state is. So if someone has contacts with Manuela Veloso and some of the other organizers of that workshop, they wanted to create a Turing championship with a lot of tasks about, but I think that the approach, and it's something that I would like to see when they just do this, if they finally do this Turing championship, is whether this is task-oriented or... So I think perhaps in the AGI community, we could do something similar, and that doesn't, of course, we should collaborate with them. It doesn't make sense just to do something because they are doing something. But first, looking at whether they are doing, is this useful for AGI? If this is useful, well, this is done. And if it is not useful, maybe starting with your work or just collaborate, creating some kind of group and starting on, let's say, why all these people are just working on their benchmarks and things. Why don't we just try to do something together? And, yeah, I don't know if you are open to that idea. Or...
Absolutely. Sounds great.
Okay.
I think part of the motivation for our framework, I'm a Chris PhD student, is also to be able to have a set of tasks that can scale from the very simplest learners all the way up to AGI. And as I understand it, the outcome of that Beyond the Turing Test conference or symposium, I think one of the main outcomes was kind of a suggestion for a visual test where the scene needs to be labeled or something like that. I don't recall exactly, but very simple learners are simply not going to be able to do anything. Yeah. And it is our hope that we can come up with a kind of framework or system where we can start with simpler tasks and more or less automatically extend them and increase their complexity and difficulty so that we can have a kind of idea of how much more intelligent the system is. And if we have a system that's not yet, perfect human level general intelligence, but it's also not the simplest learner, it's somewhere in between, then hopefully we will be able to construct tasks that are suitable for such a system. Okay, any more questions? Wait for the microphone.
So how can we go about evaluating an agent whose reward function we actually do not know?
I didn't get the question.
How can we evaluate an agent whose reward function is unknown to us?
You mean the reward function? It's given by the environment. So in the tests that we run, the reward function depends on the quality of the action that it takes, right?
But I mean, if you look at biological agents, reward function is not given by the environment, right? It's kind of like you do not actually see the reward.
Well, when you're running a test, you have to go by that approach because I think that's the only way, because it depends on the type of environment. If we're talking about a reactive environment, that's always the case, right? But in some other types of environments, I guess I don't know. I don't know if there is another way to simulate this. But most of the works in an agent environment framework is usually a reactive rewarding system.
So my question would hold for most of the general intelligent agents, right? It's not actually like a task specific, and we don't know what like the goal of the agent is, but I see your point.
You want to say something?
Yeah, so if you have some ideas of how to evaluate systems without them interacting with something, I'd like to know that, because I think ultimately, you're always bound to a certain limited period where you're actually trying to get some data that you hope will generalize to the larger scope of this entity that you're testing. Well, you have to do that somehow, and we call this a task environment. That's a very, think of that in the most general sense, not in the most specific sense. You construct something that you have the system interactive, and you have to have some way of giving the system some goals for that particular scenario. Otherwise, you don't know what you're testing for, so it's worthless.
thank the panelists again. Okay, due to us running a little bit late and giving you a little bit more time for lunch, we're shifting back the program in 15 minutes, so we're going to have lunch now, and please be back at 1 p.m. exactly. 2 p.m. Oh, yeah.